get rid of that. Good morning and welcome to this presentation from the Lighting Design Lab. Today we are going to talk about demystifying heat pumps. We've got a couple of industry experts and they will be questioned by the Eric Strandberg of the Lighting Design Lab. So I'll let Eric introduce our two panelists in a moment. So just a few housekeeping things. All of you are on mutes and that will be the way it stayed the rest of the presentation. You do have a box on your screen where you can submit questions. I will be monitoring that and interrupting periodically to ask our panelists these questions that you come up with. This whole webinar is being recorded and will be put on the Lighting Design Lab website when this is done. And after the webinar, there's a short survey. Please take that. We'd appreciate your feedback. And I will now turn it over to Eric to talk about how the rest of the thing's going to run, and he will introduce our experts. Thank you.
Yeah, well, thanks, Robert. And got an exciting presentation today, demystifying heat pumps. There's a lot of questions, and particularly about modern heat pumps. We've got Chris McKinney with Carrier here to talk about what he's seen, and Jonathan Moscatello is going to kind of lead the charge, and he's with Daikin, and they're going to help us with that because we know that they love inverter heat pumps. I'll ask a couple of questions.
Do.
Yeah. You know, one of the questions is, you know, what confuses installers about modern heat pumps today?
Yeah, we thought through this answer, and we found that there are 5 practices or special considerations that installers must make, and it's new to them. And they have to learn these 5 new practices or special ways of considering. And these practices and considerations, they break tradition with the sort of more historical or earlier generation of heat pumps, even from traditional HVAC that they have been installing, right? So it's like for installers who learn by repetition and by doing the installation work that they've been doing in a certain way, these modern heat pumps force them to stop, learn new practices, think about the installation in a different way, and that's surprisingly a big change. The first of these 5 big changes is that modern heat pumps vary their capacity. So unlike the earlier generations of heat pumps, which cycle kind of an on and an off way of operating, the new heat pumps run hopefully for a good long period of time and then modulate to increase the output a little bit, and then maybe decrease their operation, still running, but decrease the amount of work they're doing, and adjust throughout the course of the day when, let's say, changing climate conditions. So Chris, why don't you chime in here and give us some more examples?
Yeah, so you know, these systems, modern heat pumps, and the magic of these inverter heat, you know, compressors in these systems are, you know, they can absolutely slow down to produce a really relatively small amount of heating or cooling, but they can also ramp themselves up to produce a lot more when needed. But the magic of that is we call it part load. But if it doesn't need to make it, it can ramp itself down and make less. And most of the time it can get away with that. Really, these systems, their whole mission in life is to maintain temperature. There's a couple cool little diagrams down there at the bottom on traditional non-inverter heat pump. It's sort of like, imagine being in a car, starting and stopping. You know, an inverter, really, a variable speed HVAC system functions like a car does on the highway, especially when you're in cruise control. You know, if you get onto an on-ramp, let's say you take a right, go up the on-ramp, and you're going to kind of hit the gas down. Your RPMs go way up, but once you get on the highway and you find that sweet spot, then that RPM starts to ramp way down. You put it in cruise control, and then it's just right there, let's say 1,500 RPMs, and it's cruising at its max miles per gallon, a very comfortable ride. These systems want to do the very same type of thing.
And that's a real surprise for installers, isn't it? When they might get sent out to install one of these, they turn it on and they don't know how to talk. Like, what are some of the ways that might surprise or confound an installer?
Yeah, so they're all a little bit different on brands and manufacturers, but for example, some of these systems are recording time and temperature and tracking information, and they may go up and start hitting a button, and then something doesn't happen right away. You know, it may wait a second, it may wait a little bit of period of time, and then all of a sudden it'll ramp itself up because it's tracking its time and temperature, and that compressor is sort of reacting based on 5 sensors. And contractors aren't used to waiting to gather information from 5 sensors and the kind of information it's analyzing to kind of do that cruise control speed. So that's one. I'm sure, Jonathan, you probably got another.
Yeah, I'm imagining like that the customer is going to start asking some questions in the home, and I think we addressed this later, how if that installer is not sufficiently expert in how these machines do this varying of operation, right? They're not instantaneous on-off kinds of things, that the installer is kind of flummoxed in front of the customer, and they struggle to sort of explain how this stuff all works, and it doesn't create for a great customer experience. But Eric, did you have a question or something that you wanted to comment on?
Well, I was just going to say, with that varying speed, I've got a heat pump at my house, and I recall my old gas furnace. Yeah, it would come on and off, and you would hear it when it would come on, and then it would go off, and then it would come blasting on again. And my new heat pump, yeah, does that. It just whispers away quietly and continuously. So yeah, that's kind of a benefit.
I mean, I think most of the audience here have a interest in energy efficiency. This constant operation at a part load or a low amount is how these machines produce energy efficiency. So this is not a small aspect of these modern heat pumps. It is the deal for these heat pumps.
And it's also, besides even energy efficiency, it's great for comfort, but it's also great for the life of the system. It's actually easier on the equipment. It doesn't wear it out as much. The fact that it's kind of running at a part load instead of just turning on, turning off, turning on, turning off. It's really has less wear and tear on the compressor and all the parts. So these modern heat pumps are very reliable.
Good to know.
Yeah, and the other thing that Chris and I have found that in training installers over the years is that the installation is very different, and we have a few of those things to talk about. But remember, an installer who learns on the job over years the way to do things, we're asking them to break that tradition and install these modern heat pumps in a different way. And we can have them come to training class, and we require them to install these modern heat pumps. But it's a real source of cognitive dissonance for this installer who's done certain things the same way for their whole installation work life. And then here comes one of these modern heat pumps, and lo and behold, they have to break that tradition. Chris, why don't you run through a couple of these like simple installation differences?
Yeah, so there are some things that are different, and it does, how things change, difference. These are things that can make technicians uncomfortable or installers. So we don't typically, now this is typically, these modern heat pumps we're referring to, these inverter compressors, they don't use filter dryers. We meter the refrigerant on these systems at the outdoor unit, at the EEV or EXV at the outdoor unit, and they don't have this filter dryer. And if you don't know what a filter dryer is, but that's just a way that you're kind of cleaning refrigerant, getting moisture and debris or anything out of there, that alone makes traditional installers very uncomfortable because it's sort of a catch-all, or these things need to be perfect when they're installed. You use insulation on both line sets, and if you go back to the picture, I think we skipped ahead.
Yeah, sorry, I hit the wrong button.
No problem. If you'll notice, there's that copper line there on that kind of blue cylinder. That cylinder, that is the filter dryer. And nowadays on these modern systems, we need to insulate both line sets. One's a suction line, one's the liquid line, and we can get condensation and issues on the line set if it's not properly insulated. Doesn't seem like a big deal, but it is a big deal in the attic. in the summer or winter when we have problems. So those are just a couple of examples. All new models come, online. This difference is changing. Some new models use filter dryers. This is just saying we are seeing a trend now of there being some different things out there. So, but we made a note of it that we're now seeing some heat pumps that can use a filter dryer, some don't. Some use traditional line sets, some don't. The only reason we're saying that is Jonathan and I are speaking to typicals. Typically, this is what you're going to see, and typically this has been the change. So this is just one thing. I don't know if you guys have anything other to add.
No, I was thinking, there is one thing that's kind of a little favorite of mine. So if you look at this picture, the traditional heat pump, you'll notice that these refrigerant line and the one that's insulated, they don't have any weather protection on it, both ultraviolet light protection, nor something that keeps moisture from soaking that material. And the utilities in the region did some research, and I've seen this on jobs out in the field where these line sets on a modern heat pump aren't protected or insulated properly, and they become a source of energy loss, right? We don't want these pipes to be soaked with water because the insulation doesn't function when it's soaked with water. And in fact, the water wicks away energy that we want to put into the house, heat energy. And so, again, we're asking contractors to break from tradition and install these refrigerant line sets and the connections to the machines totally differently. And they can learn, but hopefully we make that learning process really short. And it's a challenge that I think we all have a role in fixing.
Mm-hmm.
Okay, the third way we're asking contractors to change is in the indoor unit, indoor side of things itself. Now, in this picture, we have a ductless heat pump as the sort of modern heat pump indoor unit. There are many different types of indoor units. Some look like a furnace replacement, like they are sheet metal, they connect to the ductwork of the whole house. Others are these independent, we call them fan coils or heads. There's a bunch of terminology, unfortunately, we use to describe them. Chris, why don't you run through a couple of the ways that these indoor unit installations go differently?
So this is just on the right hand side, that's an indoor high wall head. That's something you'll see out there common, but there are many, to Jonathan's points, many different types of indoor heads or different zonal indoor units, let's say, or ducted units. But the reality is they all kind of have some real similarities, whether it's a traditional looking fan coil or something that looks like this, they're still going to have a line set or a line that comes to it, taking refrigerant back and forth from the outdoor unit to the indoor unit, and they're going to use these things we call flare fittings. And these don't require, this is another thing, it's different for an installer when you tell them they're going to install something without brazing, where they're pulling out their traditional tanks and brazing and soldering the line, the copper lines. So they're going to use flare fittings, and it's a discipline, and it's a consistent technique that's required to prevent leaks. And one of the main issues we have with these systems is that we have what we call flare leaks on them. You really have to do it exactly right, and you got to check it. We use digital controllers. Oh, I won't get to that yet. We use torque wrenches, digital torque wrenches in many cases, different flaring tools. And you don't need to know this, but we bring it up. On the bottom right there has this spec. Well, nowadays, used to be installers would just throw their torque wrenches in their van and pull it out and just check it. But nowadays, you got to recalibrate that thing all the time, and then you need to check the spec. So even in the different size of unit, even if it's the same unit, but if it's a 9,000 BTU or 24,000 BTU, it may actually have a different torque spec, and installers need to know that. That's the difference between a good installer and somebody who's doesn't know. You just can't go out with 2 crescent wrenches and go do something that they used to do by feel. Installers used to say, yeah, just go till it feels right. And, that's a scary thing for Jonathan and I, as we kind of run these divisions out there of people doing that kind of thing. On these indoor units, they use digital controllers typically, but not always. Instead of a thermostat, there are ways to use thermostats. There are ways to use your phones to control this stuff, but typically you're going to have a digital controller that's going to talk to that, unit, telling it what set point you want. Anyway, take it from there, Jonathan. What do you got to say about that?
Well, yeah, but the only other thing I would want to say is, again, for this audience, these flare leaks used to be, for Chris and I, kind of a maintenance or service issue. The world has changed very fast, and these refrigerant leaks are now a significant global warming source or impact. The refrigerants, when they leak in the atmosphere, become just a tremendous contributor to global warming. And so, yeah, our world is changing. It's put a high premium on us to, number one, train our installers to follow that discipline. And I have to say that Chris's organization has a wonderful training class where they teach this flaring as a discipline, and I'm really impressed with that training class. And that needs to be something that the whole industry really rallies around. Yeah, because we've got work to do on this global warming issue. So, okay, moving along to the four out of 5 ways that we're asking customers or contractors to break tradition is how these modern heat pumps have their electrical connection to power them. And then, of course, how the split system, right, the indoor unit and the outdoor unit that's a part of a modern heat pump, is we call it a split system. The indoor units and outdoor units communicate in a particular way. And again, this is different than the previous generation. And we're asking installers to break with tradition and really understand that. Chris, do you want to run through some of these nuances?
Just things that would be different for an installer if they've been around a long time. The indoor unit receives its power from the outdoor unit. That's a real difference. It's also, once you embrace it, it's kind of an exciting thing as well. It's allowing for example, people to do fuel switching and things like this with furnaces. But typically, the outdoor unit powers the indoor unit. The power and the communication mostly share the same wire. In fact, that the communicating signal kind of runs around the outside of the wire, and you have to use a specific, I think we have a slide coming up on it, but they can use anything from a 14.3 or 14.4 stranded shielded communication wire or 16.2 communication wire. That's much different than how an electrician would want to pull just solid core old Romex wire that doesn't have the ability to allow for communication on the outside of the wire. That's different. Communication signals are digital. This is just not an analog on-off type system anymore, and there's things that are very specific to this technology.
Okay, and then last but not least, the 5th way we're asking these contractors to break with tradition and work differently with these modern heat pumps is around the service and diagnostics of them. And while these machines have an extraordinary reliability piece to them, I think it's, however, dependent, of course, on them being installed properly. And as we've just illustrated from the previous slides, they had installed it differently. And so what happens is, with some contractors who are new or maybe less experienced, the installer's less experienced, they hook one of these machines up and it doesn't behave right. Now they have to go through a service and diagnostic process to understand the machine. And of course, it's a totally different process. So I hope you can see how there's a build here that for the uninitiated, or let's say the inexperienced, you can have some real, you could be walking out a path full of pitfalls. So yeah, like Chris, walk us through what's different and how this.
I mean, the thing about these heat pumps is, it is a heat pump. It's still got a split system. Jonathan mentioned that earlier. It's got an outdoor unit, got an indoor unit, has a compressor, has a coil. But the technology, the board technology, the digital technology built in these are different. We can visualize problems using digital tools like this laptop shown here. We can plug it in and we know exactly what's going on with the system, from refrigerant levels to run times to codes that have tripped to how it's working. There's just, that's all you need. Gauges, traditional HVAC gauges, are not the starting place for these systems. In fact, if I ever take a phone call and I'm helping an installer over the phone, I know I got a real problem if they've already told me they got their gauges out on the system. Because we're not diagnosing it correctly. The sequence of operations is different. It must be understood in order to properly diagnose and service. And what we mean by that is there's in the board built into there's think of it like little steps. That system's going to run through each one of these little steps as it makes a decision. And if something's affecting that step, it's going to trip a code or it's going to do something. It's going to do something very specific. And it's very easy to diagnose. And we always tell installers, take a deep breath, step back, don't panic. The system's going to tell you everything you kind of need to know. Sometimes it's just knowing the temp split of the system and just the temperature of the air coming out of the unit versus the return air. Sometimes it's seeing where it tripped up on the board for that sequence of operation is not doing something correct. It is simple, honestly. I think the mistake on these is, yes, they're different, but it's also not overwhelming. It's just different and new. Doesn't mean it's different and too overwhelming, complicated. In some ways, these are easier.
And I think they are easier, but if you've got 10, let's say, years of following a traditional way of doing things, you add power to the machine, you go to the inside unit and set the thermostat to turn the machine on, and you're expecting a bunch of clicks and a couple of fans to initiate, just like you've done for the last 10 years. Well, these machines are going to be so different, and it does confuse those uninitiated. But once they learn it, as you were saying, Chris, right, they see how simple and easy and like modern electronic convenience that we're used to in so many other ways in our lives.
Right, they end up loving it.
Yeah, they end up loving it.
Yeah. So per that, what about customers? What confuses them most? They're a big piece of this whole three-legged stool, if you will. We've got the technology, we've got the installers, and we've got the users. So what's giving them heartburn, if anything?
Yeah, there's this little laundry list that you see here on the screen kind of boils down a bunch of things that over the years we've learned. Now, Chris and I both have sold these modern heat pumps in homes prior to working for the organizations that we now work for. We were contractors, and when you say, Chris, we were devotees, we loved these. Yeah. And so
Absolutely.
right off the bat, like when a customer goes from a traditional heating system to one of these modern ones, they don't have the sounds that they've been familiar with, and they have new sounds. And I describe it like this: like the human senses are incredibly good at finding differences, and when we hear or see or smell something that's not been a part of our lives before, we're really good at recognizing it. And for a homeowner who's bought this technology, spent a good amount of money to buy it, and maybe not been initiated or trained to them, they have that same cognitive dissonance that we were talking about with the installer before. In my experience, maybe yours is different, Chris. If we didn't do a good job orienting that customer, they'd be on the phone nervous and concerned.
Oh yeah.
Right?
Absolutely. It's the front end person who sells the system, and there's a responsibility there to explain it to the customer of what's going to happen with their system and why it's a little different and that it should be embraced. Sounds on here, it says sounds like, for example, one of those indoor units we were just showing you. Well, there's some crackling sounds that the refrigerant can make at certain levels. They're very quiet, but they just make some crackling and popping noises. Well, to a homeowner that doesn't know that it could make noise, thinks that's the sound of thunder, even though it's like hardly your refrigerator makes noise, but when it's different. Or you could hear noises at the outdoor unit that just sound a little different than what you're used to. So there is a little bit of education there on that. Jonathan, you have smells on here, and I know that you maybe have a story. But
yeah, and this is, of course, just a small detail, but at times we have learned that, especially with the ductless style of modern heat pumps, the unit is in the room. Unlike if you've had air conditioning, the unit is way down in the ductwork. And
right.
On some of occasions, like when you start heating in the fall and you've got some dust that's just settled onto the heat exchanger, it makes a little bit of a burnt off smell. And similarly, towards the end of the summer, if dust and so forth has gotten on that cold, wet surface, you can get a little bit of a musty smell. Now, and in all honesty, homeowners need to clean filters and take care, right? And if they don't, it exacerbates both of these instances of smell. But again, the human psyche being, or the human senses being what they are, if a homeowner is not prepared for these and told that it's normal, they can have that funny, nervous reaction. And so again, at least in the work that I've done in contracting, it's always about educating that customer the day of installation on what they can expect. And smells is one of them. It's not a huge part of it, of course, but it's a small thing. The other two bullet points are a big deal. Sounds is a big deal, but how to use the controller and the differences of that, the next bullet point here is big deal. Chris, do you want to
Sure,
run through?
I'll start on this one. You know, long or continuous run times, we mentioned earlier in the slides that these things want to maintain temperature. And the reality is, you know, we sometimes provide these lists of like 20 things a homeowner should know. The first one is, be excited. Your system may never shut off. You know, you want it to run all the time. In fact, it doesn't mean it's just drawing energy. In fact, all the energy, most of the energy usage on a system, on a traditional heat pump or a heat pump now, it's the starting and stopping. It's when it turns off and turns on. When it's running, that thing's just barely drawing any amps. You're gonna have these long run times. Plus, it's great for wicking out moisture out of the air. It's great for maintaining comfort. You're gonna have long run times, and I liken it to, I used to tell people, you know, if you filled a sink with hot water, you know, in your kitchen and you wanted to maintain temperature, you wouldn't want to just fill the sink, dump it, fill it, dump it, fill it. You'd want to fill with hot water and just trickle water and maintain it. That's what this system wants to do, wants to figure out how to do that efficiently. Now, set it and forget it. You know, nighttime setbacks are a problem. This is probably single-handedly one of the biggest issues out there. People have these expectations. You know, I mean, I even had, I'll just give you a real example, you know, just from like yesterday, there was a customer that was, they wanted to just have like a 12-degree setback. In fact, they even wanted to just turn it off at night and then turn it on and have it magically just boom, hit temperature in the morning. One, that's super, super energy inefficient because you're reheating everything in your house, all your chairs, your wall, everything's got to re-get to temperature, and then it wants to hold temperature. If you're getting into a modern heat pump, you really want to be thinking, one, you don't need to think like that anymore. It used to be that you did that to try to save energy. You were trying to have a big setback and you got used to it. But nowadays, really 3-degree setback is the max. It'd be better if you just left it there and forgot about it. You know, it's just, that's a big one. Unoccupied setbacks, those can be a problem too. Go ahead, Jonathan.
Yeah, and I was thinking too, like with these modern heat pumps, they have lots of features on their controller that we didn't have on our old ones, like the dehumidifier dry feature. Like we have had a lot this summer of days where they were like 80 degrees or 70, and we had some at least in the Portland metro area where I live, we had muggy kinds of conditions, and the dry feature is like air conditioning but on light duty. And so it really just dries the air out without cooling down, overly cooling the room. And you just couldn't do that with our old central air conditioner types. But the modern heat pumps do it beautifully. Well, you have to teach the homeowner how to use that dry function. Otherwise, they won't really understand when and why to use it. They think it's like a dehumidifier for the winter. It's not. It's a better air conditioner on a 78-degree or humid day or an 82-degree humid day. The other one is that, remember the auto function in the early days, Chris? There's a mode called auto, and that allows the machine to switch between heating and cooling automatically. It works great if you're in a high rise in like Seoul, Korea, or Tokyo, or somewhere where, you know, it might be kind of cool in the morning, but as soon as the sun hits all that glass in your apartment or condo, you'll want to be in air conditioning pretty quick. In the Northwest, it's terrible because we hover just in needing a little bit of heat throughout most of the winter. And what it'll wind up doing is heating your house up, being too warm, and then cooling your house off. And all day long, your machine switches between heating and air conditioning. Just uses way more energy.
Yeah, exactly. There's a little bit of training there, and people get, you know, we would just want you to be in all heat or all cool, and then let that compressor do what it wants to do in each one of those modes. You know, another one, Jonathan, is like you put in your desired set point on the unit, but the unit's monitoring the temperature of the air coming back to itself. And that
Yeah.
is different than a traditional heat pump where they got this thing on the wall and it says that's 68 and it's kind of making a temperature to that specific thing. Now there are ways to actually do that, so that's what I said typically, but still, you know, people will go to Walgreens and get a thermometer and say, I'm sitting in my chair and it says it's 70, 69 right here, but at the top of the, but that unit says it's 72. And that's because it's monitoring the temperature of the air coming back to itself. So that's just not bad or good. That's just how it is. So it's a little different. Yep.
Yeah. So the other thing is, of course, we educate customers on the maintenance. Nothing really to say here. It takes, there is a filter, there is an outdoor unit, there's a little bit of maintenance involved, and it's just important to make sure people know that. And for people who are working in utilities that might be on the call or around utility programs, like customer satisfaction is important. And contractors don't, I think, realize how utilities bread and butter is customer satisfaction. And again, I want to put this out there that like educating customers on how to live with their heat pump is really the trick on getting a happy customer who loves the incentive that they've received from the utility for their new modern heat pump.
Right.
So on our last question, which has a lot to talk about.
Hang on, I'm going to bop in here right now. We've got a few questions that have come up.
Okay.
First one is a multi-parter relating back to the installation, and I'll just read it pretty much as is. Are there any standard specifications for installation to reduce likelihood of refrigerant leaks? If so, where would we find them? And then are there any regulations coming out or in place for producing installation methods that are likely to reduce leaks? If so, where would we find those? And then the last part of this is they caught Chris's comment about the training, and so they would be interested in hearing more about Chris's organization training and how to find it and maybe tap into that. So that's the first question.
Chris, why don't you answer that specific training part, and then I'll kind of tackle the specs piece of it.
Yeah, so we do a lot of training on. I'd say we're downright just OCD and obsessive on leaks. One, selfishly, just for performance, but two, for the reasons Jonathan said, refrigerant's just darn expensive, and it is bad for the environment. There's all those reasons, but the main thing is when you do an install, there is exact process and procedures in place from specifications. I know Daikin's got them. I know that Carrier makes them as well. From processes like how to properly, literally how to cut the copper, how to ream it, what exact tool to use. We have everything down to like how to turn your hand when you do it, how to do this, how to do the flare, how to check it. And then we force our guys, we have classes where we make them do it in front of each other. It's one of those things, it's like a free throw. A free throw in basketball is the easiest shot, supposedly. But if we all went up in front of, let's say 500 people and we went out and shot free throws and we were supposed to make 10, it's tough. And even though it's an easy shot, and the doing flares, you really got to do it, and then you got to check it and make sure, because you don't always nail it every time. And the other thing is, once they do the install, there's a way that they're purging the system, checking for leaks with nitrogen, using soap bubbles, going around and checking for any leaks. And then even when you do startup, there's ways to check, and if they're not getting the proper temp splits, it's going to be a leak in the system. It's not done correctly. I'm going quickly. There's a lot of steps. We do have training. Carrier, we do Carrier Bryant and something I did through the Airefco network. Now, that is for our dealers, but if there is anybody in here who is involved with utilities or municipalities or anybody like that, I definitely can extend an olive branch there and tell you that we could talk about, put on some training for you all. It would be a little trickier, obviously, with dealers. But if there's anybody on here who would love to do some torque wrench or flaring training, that's a way that we'd love to interact with you and maybe share and collaborate. We love doing whatever we can to, move the ball forward. So,
yeah, your email will be at the end of the presentation, so they can reach you that way.
Yeah, absolutely.
Can I come to the training too?
Jonathan, of course, always.
I love going to those trainings. All right, so in terms of other things around specifications, so it's worth talking about how the standards work around this. And mechanical code says that we will do a flare, and it'll be per it basically references and incorporates the manufacturer's specifications into mechanical code. That's generally the sort of government, let's say, or the regulatory oversight around the quality of these mechanical connections, as we call them, or flare fittings. Now, we talked earlier in this presentation that installers learn by repetitive active learning. Just because we as manufacturers detail and in our installation manuals how to do a flare fitting, we know that humans being humans, that our install base learns through repetitive learning. So this is the origin of this problem, is that we specify it, but our installers aren't reading it and following it to the letter. And so hence we have to do this training and hope to set them on the right path at coming out of training to do it in the field. Now, right, this is, you can see where this could break down. Not every installer who touches that tool is coming through our training, and that's something that is very difficult for us. We're not a regulatory agency. We can't dictate that. We only know that that company that we sell to have a certain number of installers trained, and that's the extent to which we can manage and monitor this. And so I think our job as a manufacturer, and Chris's job also as a field level person for the manufacturer, is to just offer training as much as we can, make that training good quality, entertaining, make sure we teach the installers which tools they need to have in their toolbox, and just keep beating the bush on that. It's a constant effort. In the years ahead, in the state of Washington in particular, Washington is a leader in the state regulation of refrigerants. In the years ahead, we're going to transition from the refrigerant we use every day today in these heat pumps to a new refrigerant that's going to have a lower impact on global warming. We're going to have to train entirely our workforce on these new refrigerant. And so it's a wonderful opportunity for us to cement these good behaviors and practices in the years ahead. And it's all good, right? I mean, I don't want to say that we're in this period of major transition.
You know, it's pretty
We're
interesting.
looking forward to it.
Yeah, and I can tell you this in kind of carrier land, even with our traditional unitary products, conventional products, or even rooftop package units, things you've seen from Carrier over the years, I can tell you this, it's really interesting related to flares, because we are going to R454B, that's the new refrigerant, the new, more, globally friendly refrigerant. We're going to move to all flares, even on conventional equipment, starting next year. So flares are not going away, and that freaks installers out. But anyway, that's just a point of interest.
Yeah. And Robert, unless you tell me otherwise, I think we'll keep moving. But I feel like you may have had some more questions. Is that right, Robert?
I think we might hold those till the end. We're getting a little low on time. Do you think, guys?
Yeah.
The next section, this last question is a lot. So let's dive through it. And Chris, you and I have the job to explain a lot of this intense stuff. So do you want to?
We should have some time at the end. So I mean, heat pumps have been around for quite a while, but the modern heat pumps are different, and maybe you could explain some of those differences between the older traditional ones and the new technology.
Yeah, sure. We came up with what we think are kind of 6 differences, and a little bit of, you may have heard hints of these 6 differences, but let's run through them in turn. The first one is just the technology itself. Today's modern heat pumps have a computer, and that computer has robust software, and that's what drives this system, not a thermostat in the hallway or in the living room. And Chris, do you want to run through some of these key components?
I mean, that's a great one. I mean, so these sensors, I'll just jump right there, Jonathan. I mean, think these systems typically, now, John and I both represent different brands, but they have these kinds of things are very similar. We, typically have about 5 sensors on these systems. You have a return air sensor, a heat exchanger sensor, an air discharge sensor, an outdoor sensor, There's all these things. Think of them as like fingers, your eyes, your ears, your sense of taste. And as these sensors start collecting information, they immediately make decisions, and they start telling the compressor and the indoor unit they're working together, that indoor fan, that variable fan, and they're all those sensors, the fingers, eyes, ears, nose, mouth, taste, they're all sensing to make decisions very quickly. These are, this isn't a blunt instrument. I think older heat pumps used to be a little bit more of a club. This is definitely more of a scalpel. So it's computer controlled. It has a variable speed compressor, and the magic of that inverter variable speed ability of that compressor is based upon the good quality information that system sensors can deliver to itself to tell that compressor, which is the motor of your car, what to do. And if it's sized properly and applied properly, you're going to be very, very comfortable. That system's going to operate that modulation of that compressor, and you're going to be very comfortable. You're going to be it's energy efficient and also last for a long time. The outdoor fan, Jonathan made reference here that we have a variable speed even fan. So where that arrow is pointing, in that fan, if you sit there and stare at it, a lot of times you can't even hear it because it's so quiet. But you'll notice, even if you sat out there for an hour, it'll speed up, it'll slow down. If it was very cold or very hot out, it might speed up a lot. So you have a variable speed fan with a variable speed compressor. The indoor fan is modulated in variable speed. That's as quiet of a thing as that you can produce out there. I mean, this really is the most quiet system available. But the beauty of it is, to go back to another thing Jonathan said, which is these systems want to do, we refer to as part load, but the reality is, for the work to do in the house, if it doesn't need to work 100% to make you that comfortable, those sensors will know it, and maybe you could do it at 40%. Oh, that compressor is only operating at 40% or 25% of what it can do to make you comfortable.
And it's so different than like the traditionals, which everything comes on, the fans, the compressor, and the expansion device, if you will, like which isn't electronic. That all operates on full capacity until the thermostat says, "Oh, I'm reached temperature," and then it shuts off. It's a dumb system that doesn't have any variability or modulation. All of these things listed on the screen here, the computer can vary them independently of each other. And that's why, like, our manufacturers make heat pumps that can operate below -15 degrees Fahrenheit and still be efficient at producing heat down at that cold. You just can't do that with a dumb machine that all comes on. So just for the sake of moving, I'm going to get us to the next piece.
Yep.
Yeah, I hinted at it already, but like, as a result of all this technology, performance is just wildly different from a traditional heat pump. And Chris, I might just breeze through this one. You can see at the top a traditional on-off style heat pump. As outdoor temperatures drop, is what you see on this slide, you'll see that the performance drops. And it can't accommodate or adjust to those changing outdoor conditions. Our modern, little, compact, technology-rich heat pump can actually keep its output as temperatures drop, goes from right to left, it keeps the output constant because it can adjust fan, it can adjust compressor, it can adjust the expansion device, which is the way we meter the flow of refrigerant through the machine. And also, can we keep the performance high? We can keep the temperature that ultimately comes out of the machine, the discharge air temperature in the house, stays really hot. And so what a winner, right? I mean, it's just, you get performance, you get efficiency, all through that adjusting of technology that you see. The third thing is, and I'll let Chris speak mostly to that, these modern heat pumps, application of them, or how you put them into a home, is really different as well. And so this is a very complicated subject. We'll just kind of highlight at it. But Chris, do you want to give maybe some examples of what we mean by the differences in application?
Absolutely. So, you do always want to look at the application. A lot of folks have heard about high wall heads, which is a picture of one in there. But the reality is, and at one point you would hear people refer to these as ductless mini splits, but the reality is that's sort of a American marketing name that gave these things got a long time ago. That they're not accurate anymore because we have many options that are ducted. We have some that are ductless. We have some that are low floor, high wall. There's all kinds of ways. But the key is to distribute capacity and spread it into the house. Now, sometimes that's done through a high wall head, like seen here in that picture, or to the right, this kind of mysterious looking metal box with the ductwork that has the same internal components and guts of the other thing, but it can deliver air into ductwork and spread it into multiple rooms of the house. Now, in Washington State, we have one of the most strict building codes in the country. And nowadays, you have to bring all the ductwork in the house. It has to hit a certain efficiency level. Well, it starts getting complicated for contractors to figure out how to make these things, fit into these homes. This is an example of kind of a townhouse, and one builder and contractor figured out a way. This is how they did it. That one on the right, that box, that's a return air on the left with some fresh air coming into it, and then it goes up to a supply, and it's going to 3 bedrooms. That's like in a closet, which is now a mechanical closet, but it's taking care of the upstairs of a townhouse. That main level is handled by that high wall head. That allows you to use a smaller outdoor unit because you can, and it can potentially save cost, or maybe it doesn't save cost, but it's more comfortable. Instead of having 3 high wall heads like the one in the lower level everywhere, it's using this to distribute the air, and that one in the middle. So there's all kinds of ways to kind of apply these and take care of people, including just doing a traditional looking fan coil like you grew up with. But this is the new world we're in. Plus it's vertical, and it's very skinny. So this is just one example of a modern heat pump installation that's a little different than it used to be.
And again, we're asking contractors to break tradition and how they apply this new technology. In the past, they'd go in and say, well, you have a furnace? I'm going to put a furnace back in when it breaks. Or, oh, you want to add air conditioning? Okay, I have some rules of thumb that I follow. Now we have this incredible diversity of building stock in Washington. The new things being built have the most incredibly low energy heating and cooling requirements because of the new construction codes. And then you have older homes in the cities that are less insulated and so forth. And we're asking contractors more and more in the future to apply these modern heat pumps. Thankfully, they have that inherent flexibility, but we're asking them to turn their brain on, break tradition, and really think through what is going to be the most energy efficient, comfortable, and not break the customer's bank while you're doing it approach. Okay, moving right along. Number 4 on our list of 6 is modern heat pumps use less refrigerant than traditional heat pumps. And so this slide's a little complicated, but we hinted at refrigerant and its global warming potential in the future. One of the key ways we, as an industry, don't impact global warming through refrigerant is just by using less of it to begin with. And if we look at, let's say, an old cube-shaped traditional heat pump on the left, and we compare that all the way on the right with a modern heat pump, you'll see that these modern heat pumps use about half the refrigerant to do the work that they do. And that's great in the end. And here we tried to do a comparison of a similar capacity machine, a similar efficiency level machine. And these just were some Daikin examples, but most manufacturers, physics is physics, so there's going to be some differences here, but not very much. The trend would continue between their, let's say, traditional heat pumps and less. And we think that's really great, and it's something that I think both of our manufacturers are really gearing up for in the future. The new refrigerant we hinted at before, Chris's company is focused on a different chemical than we are. They're very similar. We all have to be using them for all of our equipment starting the 1st of 2025. And so it's like right around the corner for all intents and purposes. We have another year of using the old refrigerants before we have to shift. So it's a big deal. Number 5, available options. This is a big difference between traditional or old school heat pumps and the more modern ones. In the past, we had limited options. Now we can do all kinds of things. Chris, do you want to maybe run through some of these?
Yeah, sure. I mean, traditionally, you kind of had all electric central system. Maybe you even didn't have a heat pump. It was just an electric furnace. Or you had a heat pump system, or you had a dual fuel central system. Those were kind of your options. Or not a dual fuel, just a straight gas. But nowadays, a modern heat pump system, you've got a dual fuel central system. We can do an all electric central system. We can do a ductless zonal, which is a lot of what we've been talking to you about. A mix of ducted and ductless. That last slide we just showed you, that's what that was. Heat recovery, we haven't even really jumped into this. This could almost be another presentation. But heat recovery, meaning you can heat and cool at the same time. And then air to water heat recovery, but using the power of water to do that. This is a very exciting time in this industry. We were just having a conversation before we started. The reality is, forget about the energy savings or even efficiencies. A lot of times these systems just flat out work great, and people are just really comfortable and they like it. And this is why there's a lot of options to apply it correctly into a space. So the greater number of options makes application of a modern heat pump more accessible, and at times lower cost. Now, not always, but a lot of times you might be able to find a smaller, smarter solution to make somebody comfortable.
And that's going to be where I think we all work together, like the utility, especially a wonderful utility like Seattle City Light, which is engaged with both its customers, the citizens of the city that it serves, and also the community of contractors that it works with. The challenge we have is breaking tradition, as Chris and I have been saying along. There are all of these trended options that can fit old homes, new homes. The VRF that you see on 5 and 6, it's traditionally more of a commercial product, but it's available. All of this should produce a low-cost, more accessible way to electrify the home. But we have to all work on how to do that at the lowest cost, labor, material, equipment, efficiency. And it just involves training. People don't know how to do something until they're taught how to do it or exposed to it the first time. And that's where I think there's a really wonderful opportunity to keep partnering to do that. For my part, at Daikin, and Chris, we've talked again and again, and I've worked with others from your company. We're willing to collaborate to do that. We just need the partners in the community to invite us to the show, and let us help and do so that we can do our part, talk about these incredible options. Yeah, go ahead, Eric.
Well, I was just going to say, as a little heads up for maybe part 2, we might be talking a little bit more about the 5 and 6, those heat recovery systems.
The commercial building options.
And how they're finding their way.
Yeah, last but not least, there are these additional benefits that we've hinted at. And so maybe because we only have just a couple minutes left, we will just say that there's a big difference when these equipment are properly selected for the application and then installed well, and the customer is taught how to operate them and use them efficiently. Without a doubt, they provide better comfort and energy efficiency. And I think we've talked a lot about that, so I'm not going to say that. But Chris, why don't you hit at that? We talked a little bit. This is way more fun, right? Yeah. Tell us what you mean. What you mean by that?
I do say that, and of course it sounds cheesy, but honestly, it's the truth. I think it's fun. This is fun. Heat pumps are fun. It's fun to. We live in an era of electrification and technology, and I try to train. In my 6 states that I cover, I'm always trying to encourage contractors to understand, let's don't fight this. It's actually, don't think of it as a this versus this or gas versus electric. I mean, let's just, heat pumps, there's so many exciting things going on, so many options and so much kind of new learning. And it is fun to figure out how to use these and take care of a space. It's fun to fuel switch if people want to do that. It really is an exciting time. And I think heat pumps are fun. I think you can tell that Jonathan and I certainly enjoy this. Even two totally different manufacturers can still come on and collaborate because we kind of geek out on this stuff. I think it is fun, and we want to encourage that. There's just so much that you can do. It's a really great time. I guess I'm going to just jump in and say, what are the pearls of wisdom that we can share?
Yeah.
I'm going to just say, I'll do the first one, Jonathan, you do the second one. Installers must set customer expectations. I mean, this is key, and otherwise homeowners might get confused by their heat pump. It's critical to teach the customer how to love their heat pump. And Jonathan and I share that, we kind of had a laugh, but the reality is you got to tell them this thing's going to run all the time. You're going to maybe hear these kinds of noises, but it's so quiet. Your system's going to react like this. You might feel air that's 98 degrees, and then in 3 hours it might be 115. You're going to feel some changes. So, for example, they got to go through this list of things that are different. And I think when they do that right and it's applied right, I've never, in all the years that I've been doing this, and I've been doing it for a while, I always hear the word love. I mean, customers would get feedback. I know John is very involved. I used to never, back in the day, get people say, "Oh my God, I love my heat pump. I love it. I love it." People really do seem to viscerally like this type of product, but they got it. They can't get any curveballs. They got to kind of know setbacks. You got to avoid them. You got to know how to run your system. Celebrate that they don't have to have setbacks to save money. Go ahead, Jonathan.
Yeah, no, all true. I would say the other pearl of wisdom is that, when properly applied, like we mentioned, these machines work beyond what I think most people have come to expect from their heating and cooling. That being said, from a technical standpoint, we're seeing oversizing. So contractors invariably do this thing where they're like, they fear that they're not going to provide enough heating or cooling for their customer, and so they apply a product that maybe is more powerful than it needs to be. And the consequence for that is wasted energy. The customer will pay more for that equipment. From a technical standpoint, we can see some operational challenges that come through our service departments as a result of that. And I think, going forward, as people who work with utilities and work in community, it's just important to know that you probably, well, I'm not going to say probably, you absolutely need to do some sort of measurement calculation to determine the size of these. We call it a load calculation. You need to do that when you're putting in one of these modern heat pumps. I think you'll be pleasantly surprised. You can apply a less powerful set of equipment, and the upshot of that is it'll save the customer more on their bills. It'll save your utility that's providing the incentive energy, which is why they're doing it. And then finally, the equipment will last longer and operate better. So that's our pearls of wisdom. Here's our contact information. And I mean, we're just a minute left. Robert, do we have any more questions? And
I've
got
half a dozen or more sitting here.
We're happy to stay on, right?
Can we just go over time? And are you guys okay?
Yeah,
we'll just go.
Happy to.
All right, thank you very much. There are like 3 of these that are all related, so I'll give them all to you at one time. And maybe I'll put in one piece of commentary I have too. Okay, the first one is, it says regarding setback. What if a person sleeps better in a cold room? And I think that's maybe one sleep recommendation, that people use cold rooms. Related to that, are you saying that turning a modern heat pump off during the night does not save energy? That seems counterintuitive. There must be some nuance to that.
Yeah.
And then the third one, we use a temperature setback to reduce heat loss gain when the space is not occupied. This energy savings would not be there no matter what the control in the heat pump system would be. If we leave the heat pump on at a certain set point, we seem to be missing out on that energy savings by turning it off. I will throw in one piece of information here, and that is that my understanding is that heat pumps don't produce as hot an air as your traditional gas furnace, which is why the longer runtime and that also affects how fast the space heats up, because you've got maybe 105-degree air coming out versus the 130-degree air you used to get from your gas furnace. I turn it over to you guys now.
Yeah, a lot to say. So let's just tackle the setback. And Chris, you chime in. How about that as we go? There's finally been good research, led mostly by the Northwest Energy Efficiency Alliance. It just got published probably 2 years ago, called Maximizing Mini Splits. It was the name of it. You can find it on the NEA website. In that very comprehensive research, they finally disclosed that setting back a thermostat more than 3 degrees for comfort takes more energy to recover the thermal mass of the space than the setback provides in savings. And that was done on a literature review. Basically, the literature reviewed a bunch of research and put this finding into the literature as well. And Chris and I can attest from our experience in our own homes and in the field that appears to be true. From a sort of mechanics standpoint, we remember that cruise control sort of concept that we communicated and the part load efficiencies that result. When a heat pump is asked to recover more than this 3 degrees setback for comfort, the machine has to work in harder and operate more at its fullest capacity to try to return that space. The machines are less efficient when they're operating at their full capacity. They use more power, but the energy efficiency of that power goes down as well. And so that's a contributing factor to why setbacks are undesirable. And think about it like this: a setback for a gas furnace, let's say, like those machines are generally oversized to an enormous degree.
Oh man.
And so for them, they can recover that setback of 10 degrees, all of the thermal mass of the structure. They can do that by just a brute force approach of applying tons of BTUs and operating for a short period of time at their efficiency that they're designed to. For heat pumps, we are using a scalpel to try to cut a massive elephant apart, right? And so it's a lot of work. And we just have to run for a very, very long time because we're not producing 100,000 BTUs. We're producing maybe 24,000 or 36,000 BTUs. And we're doing it at our least efficient capacity range. So you got all the experience I have, all the research I've seen is that we have to trust that these machines maintain thermal mass more effectively than they do recovering thermal mass.
The other thing is too is we're also, I mean, in our environment, I mean, we have other states that John and I serve, like in Montana, Wyoming, other places like this, but in our area, and for the people who are on this webinar, I mean, you know, we're such a mild climate, you know, it's just the magic happens when the system's running. And these things, when they're running, pull about 3 amps of energy. Just so you know, you guys, if you plug in a coffee maker all day, that pulls more amp draw than that. So the trick with these systems is you want them to run. And that's when they're really doing what they do. And it weirds people out. But I remember back to that example I told you about filling the sink with hot water. You want to just fill the sink with just trickle a little water and maintain it instead of having to kind of bring in hot water. You know, it defies how people, sometimes even customers, they kind of fight you on it a little bit, but the reality is if you had a multi-zone system, for example, I know Eric's got a multi-zone system. This sounds crazy, but like an old school way of doing it is if you have one room and you want it to be cool where you sleep, open the window and shut your door. You know, that's a very old school thing that we're kind of seeing a comeback trend on. Now we have some technology that could, you know, shut zones down, actively cool spaces and do some things like this. But the sleeping cold thing, you know, I get it because I'm the same way, but you know, there's certain things you got to get through. That's what we meant about embracing how a heat pump works. You know, anyway, John and I literally could talk for 4 hours on this topic.
Yeah, I'm just zipping it up because I'm like, I don't want to go there in the minutes that we have.
Did you have another question, Robert?
Oh, I got several more here. Somebody's asking what the extra cost would be for a customer who asks for sizing calculations for the heat pump. Now, I know, Jonathan, you mentioned load calcs, and in my mind, load calcs should always be done. I know there's a manual J method out there that's kind of been approved for some things. So, commentary.
Yeah, this is a good one. Chris and I probably have a lot to say on this. There's a tension, like, so when a heating contractor is called out to a home to propose something like a heat pump, they don't know if they've got the sale, let's say. They don't know that the customer's going to buy for them. And so they're reluctant to put in all of the work required to do this load calculation. And so the customer, on the one hand, it's a very chicken and the egg situation that we find ourselves in. I can tell you in the past, I just did a load calculation regardless. Now, it takes probably a good hour or more to do a proper job on a load calculation. And so my recommendation is the homeowner and the salesperson have to figure out within the first few minutes how much time they have on a sales call, and two, where the customer is. Have they talked to a bunch of contractors? Are they kind of made the decision to buy? It's a very delicate conversation to have, but a good salesperson should have that conversation without making the homeowner feel like uncomfortable in any way. I learned eventually how to do that, and my process became sort of giving a customer basically some sets of quotes based on my estimate of the size of the heat pump from my experience. I'd say to them, give them a price range that I could be pretty sure was right. Then once they decided they did want to buy from me, then I would do the load calculation and put the work in. I do not like seeing contractors charging the customer to do the load calculation. To me, that's a ham-handed way of them not refining their sales process to get the value they need from the homeowner. They got to put the work in to get their sales process right, is what that tells me.
And I can tell you, it's the same thing with the carrier wants. We want load calcs, and I'm not saying everybody does them, but we want them. We recommend it. In fact, we recommend room by room load calculations. So for everybody who's still listening, Jonathan and I know both share this philosophy, but there's a trend to do what we call a block load, and those can be effective, but room by room load calcs are even more effective. There is manual. You mentioned manual J. That's definitely an ACCA standard, but Jonathan, I know, does training. We do training on a free utility software called Better Built Northwest. That's a great software, and I'm sure you guys subscribe to that, but that's a great software that can be had by contractors out there. I would definitely demand a load calc. Manufacturers want load calcs too. We don't want our systems to be oversized.
Robert, let's just do one more question, and then we'll wrap it up. How about?
Okay, let's see. Oh boy, I got a lot.
And if anyone has questions, feel free to reach out to us or to Jonathan and Chris to do a little follow-up.
I'll just ask this one then. Is there a certification for the installers so that so that these joints and stuff are done right? Are they certified, or is there some sort of certification for those guys?
Yeah, we do I wouldn't call it quite a certification in the truest sense, but we accredit our installers when we train them. And in the past, we have given certificates of completion of the training class. It's a tricky thing for manufacturers and for and our distributors, because in our system, the contractor's the expert, and they're required to acquire that expertise themselves. We make these things and we sell them through our distributors, and our trainings are limited to teaching how to apply our equipment and install it. But there's a gap there that leaves the contractor in the driver's seat for acquiring their own expertise. I think, as we mentioned, Airefco has identified, for the sake of their Carrier and Bryant equipment, that they want to go to a next level and provide that expertise in making the refrigerant fittings. But Yeah, I think we can't lose fact of that the contractor is a licensed contractor and they are the expert in this space and they do have to acquire that training themselves. The training is available out in the marketplace. I wish it was more available, to be perfectly frank. When I got started in this industry 20 years ago now, I went to a week-long load calculation class that was put on by a manufacturer and their local distributor. And we need to return to those days, in my humble opinion. And I think that our utilities and people in the field can be helpful and influential on returning there to being more training for contractors that are in the field. Trade schools are for new entrants, workforce development thing. We're talking for people who are employed currently and they're seeking their professional professional development type training. Chris, what do you think?
I mean, I will say this because I know they do, contractors definitely have to have licenses and electricians, like there's licenses and things they have to have. But for these certifications, I will tell you that, at least in my 6 states, that it's true. Jonathan's right. I mean, we're based on contractors, but we won't sell gear to contractors that haven't done at least a minimum level of training on the gear. Like we won't even we won't sell it to them. And that's because,
yeah, it's true for us too.
It makes, now that doesn't control everything. Like Jonathan's talking a little bit a higher level, but that's how important it is. More than ever, training's critical. These are things people should be asking customers. They should be able to flush these kinds of things out. That's why a kind of a one-man show and an unlabeled truck that's not connected, as a licensed kind of a certified contractor, that's why that's a problem. It can be.
It's a different time that we're in, and I won't take too much long to say, like, things like Yelp reviews and all of the various reviews do disclose when a contractor is doing, let's say, work that isn't excellent. And when a contractor doesn't produce excellent work, inevitably a piece of equipment becomes troublesome and needing lots of service, or it doesn't leave a customer fully satisfied in terms of their comfort. And that eventually comes out in the Yelp reviews. And so we live in a really interesting time where we can have this information. And I would encourage any buyers out there to, instead of going down the wormhole of asking a contractor for all of their credentials and certifications, which some have nicely prepared for people to view and some don't, is to also look at the Yelp reviews or the other various reviews that might be publicly available. And I think that they can be pretty reliable, certainly when they have enough people reviewing.
All right, thanks, guys. We have a couple more wrap-up slides, Robert.
I think that you guys have some more slides.
One more.
Yeah, next, please, Jonathan.
Yeah,
Oh, there we go. I went too fast. Sorry.
That's all right.
So yeah, this was round 1. We'll have round 2 next week, covering some additional stuff. Maybe I can pull something out of the questions. We'll see if we can get that put in there too, and then go on. And this is the Lighting Design Lab and Eric's email to contact them. You also saw Jonathan's email and Chris's email earlier, and all of this will be posted on the Lighting Design Lighting Design website in the next week or so, and so you can review it all then and get it that way too. So I thank you all for attending, and we will call it a show for today. Thank you. I hope I can go back and find those questions or maybe see what they're